Okay, we're on problem 18. We're still in exercise 69, by the way. And 18 is a rather simple problem to read. You know, the sum of two numbers is 5, and the sum of their fifth powers is 1025. Find the numbers. What's difficult is solving the system of equations. But what I'm going to do is I'm going to go to the whiteboard, and again, I want to give you a chance to try it on your own. As the old saying goes, if you can do this on your own, there's really no reason to watch me do the problem. It's for those students that are struggling with the problem, all right? Now, granted, when I go through a problem, I'm not saying it's the best way to go through a problem. It's the way I go through the problem, all right? So I'm going to, let's see what I can do over here. I'll go to Handwritten Notes, and I want to start writing. And the first thing I just, read the question again. Let me just erase this stuff over here, get rid of it. Let me blow this up a little tiny bit. And I can start writing down what they said. And the point of writing down what they said is not to memorize what they said, but to understand they have two numbers, right? So to say the sum of the two numbers is 5. And certainly there's a lot of numbers that will add up to 5, by the way. So I'm going to say the two numbers are x and y, and they sum up to 5. The next thing they tell me is the sum of their fifth powers. The sum of their fifth powers is equal to 1025. And again, I'm not memorizing that, I'm reading that. Okay, here comes the tough part. I got to do things. And one thing I'm looking at the x5 plus y5, and I'm going to factor it. All right, so I'll write that down for you. So x5 plus y5, it is factorable. And what are you going to get over here? X plus y times x4 minus x cubed y plus x squared y squared minus x y cubed plus y4. I just want to check it out. Make sure some of the exponents sum up to 1, 4, 3 and 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, 4. Let's see if the x goes down by 1, 4, 3, 2, 1, none. And let's see if the y's go up the other direction by down by 1, 4, 3, 2, 1. Yep, looks good. All right, now what do I notice about this? I know the x5 plus y5 is 1025. I know what x plus y is, and x plus y is 5. Now what I want to do is I want to get an equation and one unknown. So I'm going to use the first equation now, and I'm going to say y is equal to 5 minus x. Yeah, it's tedious. So what do you get over here? x4 minus x cubed, 5 minus x. Again, I want to get one unknown, by the way. I'm doing a substitution. Plus x squared, 5 minus x squared, minus x, 5 minus x cubed. Boy, it's going to get really jammed in there, isn't it? And 5 minus x to the fourth power. Let me see if I've written that down correctly. And so x4, x cubed, x squared, x, no x's, 5 minus x4, 5 minus x cubed, squared. Yeah, all right. So what I'm going to do now is divide both sides by 5, and you can get 205. It's tough, though. Again, what I'm saying is that, I really think it's so tough you might want to consider using a computer algebra system to multiply things out sometimes or do some arithmetic. But, you want to practice, all right? Now, if you did this over here and you expanded this, and it's work. So I'm gonna say it's work to get what I'm getting next. I'm not writing all the work down. I don't want to bore you with the details, all right? But to do the next thing up, it took me some effort, but I'm not writing down all the effort, by the way. Just writing down the results. It's 5x4. Well, that was easy. I can do that by the way. And then you're going to get minus 50x cubed. That took me some time to get. And then you're going to get plus 250x squared. Yep, it took me some time to get that too. And some paper, of course, minus 625. And then plus 420. Yeah, it took me effort to get there. All right, so it took me some work to get there. Now, I'm looking at this thing, and it's a fourth degree polynomial. It kind of looks crazy to me, but I'm going to keep moving forward. So you can get 5x4 minus 50x cubed plus 250x squared minus 625x. And I'm going to take 205 from both sides. And if you took 205 from both sides, oh, you know what? I made a mistake. I copied from my notes wrong. That last number is actually 625, and sorry about that. I just noticed it, all right? But if you took 205 from both sides, you would get plus 420. What do I notice now? I notice it's divisible by 5, which makes it much easier for me to deal with. And what are you going to get over here? You're going to get, this is pretty easy to do, by the way. I'm dividing by 5 now, both sides by 5, by the way. So minus 10x cubed. It's much easier now. And then you're going to get 50x squared. And then you're going to get minus 125. And then you're going to get plus 84. All right? So someone says, you know, it's a lot of work just to get there, and I'm still stuck. It's a fourth degree polynomial. And certainly at Essex, what we do is we really kind of rely upon the rational root theorem in the hope it's going to work. Rational root theorem. And what's it going to be? Well, plus or minus the factors of 84 divided by 1. Well, you know what? You know, starting easy, you know, I would say like numbers like 1 and 2, 4. I think you get the idea. I don't want to go on too long, but eventually this will get to the number 84. And they're the factors of 84, by the way. By the way, I'm just hopeful, all right? What do you mean you're hopeful? I'm hoping I can come up with one of the roots pretty quickly. So, you know, which one would be easy one to check? 84 would be crazy to check, but I'm going to make a guess at it, a stab at it. I'm going to say x equals 1 as a root. So I'm going to see if that's true. So what would you get? 1 minus 10, right? I'm just plugging. And by the way, if you're wondering where I'm plugging it in, we're plugging it in here. All right, I want to see if it's true. So 1 minus 10 plus 50 minus 125 plus 84. Well, let me add up the positive numbers first. So what do you get? Let's see, 85, that'd be 135, right? Minus 135. Well, lo and behold, I found the factor. And what's that factor I found? I found the factor to be, I found the root to be 1, so the factor would be x minus 1. So I know there's a root, all right? I did my little baby work, and I'm going to erase that now. So I know this is good. All right, so I'm going to write that down for you. And I know that this thing here, let me write this down for you. I know I'm getting 0 equals x minus 1. Now, I hope you realize if I continue to factor this guy over here, there'd be a cubic here. There'd be a cubic there. So what I want to do is, I'm going to cut to the chase over here, but I want to point out, you know, the next number I'd probably go to is 2. And then I'd probably go to 4, so forth and so on. Now, 2's not going to be working out for me. Now, someone says, how do you know that? You could try it. I'm not saying you can't. So I'll put that down for you. If you put 2 down, you know, if I do it, again, when I do it, I'm just going to little side work on the side. You know, 2 to the 4th power, 2 times 2 is 4, 8, 16. I'll write this over here. Minus, that would be 80. It's simple, right? You get, let's see, that would be 4 times 50, which is 400. And then you're going to get minus 4 times 125. Let's see, 400. That's 500, right? And then you get plus 84. Well, if you look at this, again, just, you know, kind of a quick scan over. What do you get over there? This would be minus 100. And then you get minus 180. I'll put this over here. And there's just no way 60. That's just not going to work. All right, so that was, I'm not going to say a waste of time, but it's not going to work. Surprisingly, though, 4 works. All right, now I don't want to, you know, bore you with the details, but again, I don't mind using calculators. You know, use a calculator if you want. I don't mind. All right, but 4 does work. So let me write this down for you. So it would be x minus 1, x minus 4, and then what would you get over here? Well, if I divide that thing by those 2 linear factors, I'd get a quadratic. All right. So what I want to do is I want to go through that work for you. All right. The way I'm going to do it is expand the x minus 1, x minus 4, and that would give me x squared minus 5x plus 4, and I'm going to divide it into. Now, someone, of course, going to argue now that they don't even remember what the original problem was. It's true. I'm on the road. I'm taking my journey. I'm not worried about where I'm going or where I've been. I just want to go forward. So what do you get over here? And I hope you're going to get into a subject area where you want to go forward. Now, certainly, the remainder theorem here, if I'm correct in my roots, is going to give me a 0. And that's a good way to check yourself, too. So what do you get over there? Well, it's got to be x squared. I'll put this over here. And what do you get there? x4, let's see, minus 5x cubed. I'll be very careful. And then it's going to be plus 4x squared, right? My line here. Go through my divisions. I'm going to subtract now. You get minus 5x cubed. All right, then what do you get? Plus 46. And again, I like to drop everything down because I don't want to forget anybody. Let's repeat. What do you get over here? Minus 5x. Let's see what you get over there. You would get minus 5x cubed. And let's see what you get there. You get plus 25x squared minus 20x. All right, things are looking tough. Not really. What do you get over here? Let's see, 21x squared minus 145x plus 84. What are you going to get over here? Plus 21. Oh boy, let's see what we get over here. 21x squared. 21 times 5. Oh, I must have made a mistake somewhere. I did. I made a mistake. And someone said, how'd you make a mistake? I wouldn't get a remainder of 0. So what I want to do is I want to correct my mistake. And this happens to you when you're doing work. You want to say, I got to correct my mistake. And my mistake is over here. And my mistake is going to be corrected now. That's going to be minus 105x. All right? Let's go back. What's 21 times minus 5? It's minus 105. Well, now I'm getting what I want. And what's 4 times 21? That's 84. So I am getting what I expected. I'm expecting to get a 0 remainder. So what's the remaining factor? It's x squared minus 5x plus 21. All right? Now, by the way, certainly someone says, do you know where you're going with the problem? Not really. But what I want to do is I want to see what the roots of that guy are, right? So I got, x squared minus 5x plus 21, that factor. I want to find out what the roots of that is. And this x squared minus 5x plus 21 is equal to 0. And I'm not going to do that with my fingers, by the way. It's just not going to happen. And the reason for that, the factors of 21, 3 and 7 or 21, 1, it's never going to be 5, right? So I can use quadratic formula. And again, you can use the methods that you like. Some people want to use completing the square. There's nothing wrong with that. Twice a goes on bottom. The a is the coefficient on the square terms, and that would be a 1, so 2 times 1 is 2. The opposite of the coefficient on the linear term, which would be 5, plus or minus. This is always a tough part for me. That linear term's coefficient square, which is 25. Whoops. I don't know why I do that. I say things and then I write the wrong thing down. So let me get my eraser out again, and I'll erase this guy right over here. And I realize sometimes it puts me into a bind. I make mistakes, and I don't know why I made mistakes. And I look over my work, I can't find it. So 4 times A, what's 4 times 1 is 4, times C, which is 21. So I'm getting some numbers over here, and I start to realize they're complex immediately. So what do you get over here? X equals 5 plus or minus the square root. There's a 2 on the bottom. And let me write this on the side for you. So it's 25 minus, I'm sorry, I did it again. 25 minus 84. All right, so let me write this over here. 84 minus 25. That's 7, 14. I see 5, 9. So 59. All right, so it's minus 59. So what am I going to do now? X equals 5 plus or minus I root 59 over 2. So I found 4 x's. Let me write them down for you. What are the 4 x's going to be? X is 1, x is 4, x is 5 plus I root 59 over 2. X is 5 minus I root 59 over 2. Now someone says, what are you looking for? And certainly I'll go back and read the problem to you in a moment, but I think I know what y is, right? It's a long problem, I know that. Y is just simply 5 minus x, all right? So what's y again? Y is just simply 5 minus x. all right? So what do you get over here? Well, the y would be equal to, let's see, 5 minus 1 is 4. But would this y be equal to, well, 5 minus 4 is 1. And relatively simple. I mean, these are really simple to do. What's the y over here? A little more difficult, but I could write it down for you. And what's it going to be? Well, it's 5 minus the x, right? So 5 minus whatever the x is. But I notice that x is, there's a fractional part. So I'm going to really say the 5 is really 10 over 2. So 10 over 2, which is 5, minus whatever the x is. And what are you going to get over there? Well, let's see what you get. And I'll write this down for the y, comma down at 2. And let's see, it would be, 10 minus 5, which is 5, minus I root 59. And let's do this one over here. What's going to be y equals, there's a 2 on the bottom there. And, 10 has minus that x, so 10 minus 5 is 5. And minus and minus is plus I root 59. All right, again, we're doing the xy pairs over here. Now, someone says, I don't even remember what the question was. I want to go back and read the question to you and see if we've done it correctly. And I got to look at my notes again. So, certainly looking back over it, I got these, and they were relatively simple to get, by the way. Did I get the other solutions to the problem? And I'm looking at the listing of it. And let me take a look at this thing, and I got 5. I got this one. I got this one. Let me see if I got this one and this one. Yeah. But anyway, some of the two numbers, blah, 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 and some of the powers, find the numbers. So I'm just looking back over the solution over here, and certainly they give me the solution, and too real, too complex. And they give me the graph, and the graph is going to be figure. And again, please look at your notes, by the way. We provide graphs for you to look at them. And that's according to this set of notes anyway. That could change, by the way. What I mean by that, sometimes the numbers change because the problem sets change. Either I delete something, insert something else. Let's take a look at it. And I'm clearly seeing, kind of like a nice picture with 2 points of intersection as expected. Now, when I say 2 points, we're graphing in the real plane. Thank you so much for paying attention, though. And I hope you're struggling with these things. And I really do mean that. If you're not struggling with your academic work, you're really, that's not a good thing to be doing. You should be struggling. Struggling is a good thing in your academic careers. All right? Thank you so much.